and we can taking a look at some analytical tools like R, SPSS, and SAS, and compare various analytical tools, compare the three of them. Before moving to R, let's say, because we'll be talking about R, we're using R for this course. So what are the objectives we're looking at? Features and importance of R and SPSS and SAS, and also compare the tools. So, as you all know, the analytical tools are used to prepare data for analysis, execute analytic algorithms, assess the result of the analysis. It can also be used to automate analytical tasks. Talking about the evolution of analytical tools in 1990, in the late 1980s, user-friendly tools were not available compared to this time, and also analysis were done using a mainframe, and job control language was used. And talking about the late 90s, we have coding interface migrated to new platforms, and rudimentary graphics were implemented, whereby you have to code to get some things done, compared to this days whereby it's just simple drag and drop, and there is no much coding compared to these days whereby all the coding has been done at the back end, just have to drag and drop. But also the knowledge of coding is also important, because if you don't understand the basic knowledge of coding, you might just end up dragging and dropping what doesn't make sense. You also have to understand the basic programming to understand what the dragging and dropping is doing at the back end. Talking about analytical tools, we have statistical data analysis tools and also data visualization tools. And all commercial analytical tools come with GUI, which is the graphical user interface, whereby you can see what you're doing. And also, the development of tools started from tools with no user interfaces to tools with sophisticated interfaces. And with the help of above tools, focus has shifted from coding to utilities, that is drag and drop. And talking about data visualization tools, advanced analytics is not confined to only analysis of data. The result obtained from the analysis of data need to be presented in forms that are useful for the user. As well as humans comprehend or get to have a feel of what they see than just quotes. Like we want to explain a dashboard or report to executive now. You can't be telling them, showing them codes, they won't get to understand the logic. But if you can show them visuals that okay, between this period there was a 50% decline, and they can see it with visuals, they get to relate with it more than just writing a bunch of codes. Oh, so talking about some analytical tools. First of all, starting from R, which was initially developed by Oba Gentleman and Rose Biaka, hence the name R, which is a descendant of the original S package. So S was an early language for statistical analysis. So an R is an open source statistical computing package, which was used by a large number of analytical professionals. It's starting from all those academia people, so it's more like a statistical package. But getting to this point, it has really evolved, and it's widely used around the world, though it's not that popular compared to Python anyways. Features of R includes object-oriented, can be linked with common programming platforms like C++ and Java, which make it possible to embed R within applications. You can embed R with, R can be embedded with Power BI, can be embedded with, you can use R to connect with even databases like Oracle. So it's a very good platform. And also, I think Python too can do some stuff like that. And also, most commercial analytic tools have enabled how to be executed within their tool set. And they is majorly used in the academic and research environment. And what are its limitations? Scalability. So the base how software runs in memory as opposed to running against files, which is also one of its challenges. But and I also explained in-memory computing when I was doing a summary of a revision yesterday that it's faster but not cost effective when it comes to um, trying to get in touch with a large size of data. Now, how analytics data set the size of the memory available on the machine, and most machines do not support large memories. Thus, for large organizations, have turned out to be an unrealistic solution to build big data. And programming now is also a fairly intensive process because architects are less mature than interface for other commercial tools. So it's actually very intensive process. It requires a lot of coding, but it's actually interesting when it comes to statistical analysis. And we have the SPSS, which is a statistical package for social science. This social science. Yeah, this is an analytical tool that was first introduced in 1968, though its name changed to IBM SPSS when the IBM group actually acquired this business, and it has a user-friendly GUI. Mostly, it's very common in undergraduate when you want to use to analyze and the data set. They mostly use it's more common using SPSS compared to other tools like Python and R. And SPSS commands are executed line by line, and the executed syntax can be stored within their execution times. It can also read from and write to ASI files, databases, and tables of other statistics, so it can connect even to databases, provides data management functions such as sorting, aggregation, transposition of tables, and also to merge one or two tables, two or more tables together. Um, then talking about SAS, Statistical Analysis System, it was founded in 1976 in IBM mainframe world to handle large data volumes. Its capacity of handling data increased with the implementation of a parallel architecture. The SAS is an information delivery system that is used to represent a modular, integrated, and hardware-independent computing package. And some of its features include statistics, can be used for data mining or text mining, data visualization, forecasting, forecasting future events, and also optimization. And so it's also designed for to deliver universal data access, that is, you can access data from anywhere. Also provide a good user interface compared to R, increase the functionalities of applications in software, and also it provides a variety of analytical procedures that analyze the most precise information. Um, uh, okay, so it's also used by social and behavioral scientists to perform various types of functions such as spreadsheet analysis, data access, and also its products can be sold separately or in sets. SaaS solution offer a number of techniques and process for guided decision making. So you might you might just maybe get a part of its products for your own use instead of getting the whole set, or you can also get the whole set of the products, SaaS products that you use. So here are the comparison between this set of analytical tools, talking about how IBM SPSS and SAS, talking about user interface, how is least visually interactive analytical tool, and editors are available for providing GUI support for programming in R, while IBM SPSS supports a moderately interactive GUI, which is more interactive compared to R, but SAS has the most interactive graphical user interface. And in decision making, R is a large application of key algorithms to provide lesser user-friendly solutions, while for SPSS provides the best and economical statistical solutions. And SAS requires use of external data mining suites for better decision tree approach. Um, 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 what other things? In data management, they have support for data management techniques as data has to be loaded into the memory for execution each time, while SPSS provides moderately performing data management techniques, but SAS provides excellent data management techniques in that regard. And for documentation, R has easily available elaborate documentation tools. And for SPSS, due to its limited use, SPSS lacks elaborate documentation of its function and packages. So hence, R can be easily, if you get stuck in R, you can easily refer to the documentation and you get your solution and get moving. And for SAS, has a comprehensive technical documentation of more than 8,000 pages. Okay, I think that's going to take us to an end of this module. Shocking. And for the for this session rather. So in the next session, we're just going to have like full field. So it's going to be more practical in this session. Oh, oh, I've not deleted some. I didn't hear that sound. I was even like, uh, I'm very, very sorry for that. I'm very, very sorry. Hello, Ayola and Amos. Can you hear me?
Hello, how are you? I can hear you.
I'm very fine. I'm very fine. Sorry, I realized I didn't realize everybody, people were waiting in the guest room. I didn't know. So basically, I just finished going through the second session, which is talking about analytical tools. So it's nothing to worry about. It's something you can actually go by and just look through. So it's nothing special. But luckily, we just want to enter into the practical session, like bit by bit now, starting from the practical session. So I think we have not missed anything in particular. So let me ask, how many of us have gotten the lab virtual lab machine or virtual lab environment setup? If you have the lab manual downloaded on your PC, Ayola, you have it already, right? Hello, Ayola, can you hear me? Oh. What about Mr. Osajo? Mr. Amos, can you hear me?
Yes, I can hear you very well.
Okay. So if you don't have the virtual lab downloaded, uh, hopefully I believe we are going to download it before the end of today. Then we can help install it later in the week. But if you have House Studio installed on your PC, we can follow together for this class. If you have House Studio installed on your PC, you can follow together in this class. So I will start from this session talking about exploring app. So In this session, what are the objectives you cover? We will to distinguish between various editors like RGUI and RStudio and their components. Also talk about developing scripts for execution in R and execute the developed script in R. So let me open RStudio so that I can also show you at the same time go over the slide. So this is RStudio. This audio it's what's it called it? I already have my taskbar here, so I'll just click on open. So for this RStudio, it has 4 windows. You are going to see, so it has 4 windows. Now this my this one has been internet mode. Let me allow someone into the class. Not for now. You can use it, but I'm not using it. So if you don't have the RStudio installed, you can install it on your PC. But first of all, you have to download R and install it, then download RStudio and install. But if you have the VMware, you can start your VMware. RStudio is already installed on your VMware, and you can use it from your VMware any which way. So this RStudio, it has 4 windows. This is the first window that is at the left top corner. We have another window at the left bottom, and now we have another window at the right bottom. You can see my mouse. And you have another window at the right, so at the right top and at the right bottom, making 4 windows. We are going to talk about these windows as a process. So let me go to slide again. Now, so talking about R, which is a programming language used for performing statistical operations, it's open source and is implemented by our core development team. And R is available from the R project website at www.r-project.org. You can download R from there, and you can download RStudio from their website also. Not, you can not get it on this website anymore. So if I want to download R, you can just I can just go to open a new tab, then I'll just type download or I'll download. Maybe I want to type it I'll download. Then the first page I want to see is the R project site. Click on this. If I click on this, I can say download. This is the latest version. Then I'll click on this to download R. After I click on this, it starts automatically download. When it's downloaded, I install, and I've installed that, and I proceed to download RStudio. Then if I just type RStudio download, then after I've done this, you will see the RStudio website, which is preferable to have. Preferable to download Arrow and RStudio. For me, I will, if anything that you want to do using R, you can just download it on your local PC and you decide about it to open the menu. You might not find it very friendly sometimes. You might encounter some problems. If you are not, you might not be able to handle it by yourself. So since you are working on R, I'll just prepare it first, use it out to look at it on your machine. The data sets you'll be using for the lab or the practical, I'll just forward it to everyone that's in the class. So I'll click on this first link, download RStudio. Then you are going to see whether you want to download for maybe Windows or something. Automatically, I think it's for Windows. So if you see, this is the RStudio desktop, which is free, which you can get. I just click on download time. You should start downloading. Then you can see here that you have what's it called? You can just click on here also. So this is for Windows, this is for Mac, this is for. So you can just click on this one to get it, and then download, and then install. So going back to the class. So what are the major features of R? It has security data handling and storage facilities, support a large pool of operators, for performing operations on arrays and matrices. It has facilities it aims to report for the analysis performed in form of graphs, either on screen or on hard copy, if you like. Then talking about working with scripts, so how is utilized as a statistical processing environment for solving problems and provides the freedom of selecting editing tools to interact with the native console. You can use the editing scripts that comes with the House Studio. How can you go about that? So this part is called the editor. The editor window, this left top corner, yes. So this is where you can write the whole. It's like editor window where you can write your codes line by line for running everything. And this is the console where you can just type in your command and run it line by line. Anyways, so this is where you're going to see. This is where the code is going to be running, and you're going to see the output. So this is where you can edit your code. So moving forward, the developed house script can be executed in the selected editor. So the prominent editors available on R are the RGUI or House Studio. The RGUI is the normal how you downloaded from this R project, from this their site. So if you want to see, you can just type on your computer R, just type R, it's going to bring out. You have it. I don't think I have it. It's not here. Let me just find that way. Sorry, I can just download from the website here. So click on download. So, as you can see, it's already downloading at the bottom here. When it's done, I can install. So it's done downloading. Okay. I just need to click on it. So then the House Studio, which is what I just put, yes, and the House Studio, which is what I just opened now. Okay. These are the agreement. Next. Alright. Okay. Then select. Already you have to install index program. Yes. Yes. You can to install and install. It's installing already. So you have the RGUI, which I'm going to open after this guy has finished installing. And the House Studio, which is what I just opened here. This is the editor on the House Studio. So moving forward, uh, so what happened? So talking about the RGUI is the standard graphical user interface provided on downloading and installing R. So the console window in R. Oh God. I don't know. This thing has already been installed, but I can't just find it. Whether it's popping up this way. Okay. Yeah. So the console window has Also has tools to manage the R environment, and the RGUI can be accessed using the many shortcuts created during the installation process. After you install it, you can see the RGUI shortcut on your desktop. But by default, it's on your desktop. So the R comes a greater than symbol, which indicates the place where the user can enter commands. It's also similar on House Studio here. If I go to the House Studio here, you can see the command, this greater than prompt here that is blinking. You can see the greater sign. So that's the console where you can type in the commands and what. So, uh, so, um, so to quit an active house session, type the following code in the console after the command prompt. Q, then put open and close bracket. So that's going to exit the it's going to exit the window. I don't know if you can use this from the out console or from the out studio console. So let's try it from here. Here you can see that it's asking that if you want to save any changes that you made to your project. If I save it, it's going to close. If I type save, it's going to save and close. I don't close save, so it's not going to save and it's going to close it. So right on this. I'm having an error. So it's going to close. Then it's starting the session anyways. So no. So it's going to close the session and close out. But on if you're using the RGUI, type Q command and open brackets and close bracket, it's going to exit the window. Also, let this mouse be. Talking about the House Studio, House Studio is a code editor and development environment with the following features: code highlighting, automatic bracket matching, code completion, easy access to RL, easy exploration of variables and values. I'm going to show you how this applies on House Studio. So first of all, code highlighting. So what do you mean by code highlighting? I'm going to open a new script. So if I want to open a new script in House Studio, I will go to File here. I just at the left top corner here. I click on File. You can see New File. Then you can see House Script. So I click on House Script. Then you're going to see an empty editor come up. So if I want to perform any operation, let's say I want to do, I think this thing is too tiny. New file or file, new file, then House Script. So let me enlarge this. Yeah, this thing to see visually. So okay, I think it's better. So if I want to run 2 plus 3, and I type 5 plus 7. Now, if I just want to run this first line, I can just highlight and run. I can manually come, sorry, as I've highlighted, I can manually come to this run button and click on run, or I press Ctrl Enter. Any which way is going to run the command. So if I should click on run, you can see that that's run the first line and did 2 plus 3 and gave me 5. Also, I can also highlight and press Ctrl Enter, as you can see the same result. So that's code highlighting. Now, the second feature is what is automatic market batching. So what do you mean by automatic market batching? So automatic market batching is that, okay, suppose I want to run this command now. Now, board mass, we have board mass called brackets of the elementary mathematics, brackets of division, multiplication, and stuff like that. Now, if I do 2 plus 3, if I put a bracket, I can see that I just did open bracket. Automatically, it did the close bracket for me. That's what we call bracket matching. If I do use another kind of brace, you can see it gave me the second brace that closes the brace. So it just completes the bracket for me. That's what we call automatic bracket matching. So 2 plus 3, and I can put something like 5 divided by 6 here. So, and what happens is that, let me just put an operation sign here. So first, it does 2 plus 3 for me. So I can do this. So that's automatic bracket matching. I can run this. I can see the results underneath using Control Enter. So you can see that when I ran this command, I didn't highlight. I just did Control Enter. So to run a single line, your cursor has to be on that line you want to run, and you press Control Enter. It's going to run that single line, as you can see. But if I want to run all the commands, or everything I've written from top down, I can just say Control Shift Enter. You can see it ran everything from top to the bottom. So you can see it did something like source, blah 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 blah. So it just makes use of this source function, this source button. You can use source button to source a script, even a saved script, whether you have written a command in the script, you name it something like maybe my code, and going to be saved as a .r extension. As you can see here, my script.r for this script. So all your scripts is saved as .r extension. Then if you want to run a particular script from top button, you can use the source command. If you have already opened that script on RStudio, or you type source, then put it into bracket the name of the script. If the name of the script is my script, then you put .r. So if you have a script called my script.r and you want to run the command inside this script from top to down, you can type source, then type the name of the script you're trying to run in, put it in quotes, then run it. So it's going to run everything inside the script from top down. So you can see that keywords reserve words are highlighted with this kind of color. So for you to know that, you can see for, you can see this is a keyword, then put else, you can see the kind of color they use to highlight it. So moving forward, they say code completion. It also helps with us code completion. So how does that work? Okay, these are already finished. So let me open my ArcGUI for me since I finished installing this. I'll just have, you can see, come on. If you can't find it, you can just go to the desktop. It's going to be on desktop. So you can see it's already open on my desktop. This is the app. I just include the side of it. Okay. So I'll just open this. This is my app. If I should open this, this is my ArcGUI. This is how it's going to look like. If I want to type anything, this is the console. So if I type 3 plus 4, then I have 7, then any command I want to type, I can type it here. If I want to open a script that is an editor, I can go to file, here, new script. Then this is where I can edit, type anything I need to say. Then I can down name or this anything I like. So if I want to close, so if I want to close this ArcGUI, I can just type Q and open and close brackets like this, as I showed earlier, then enter. Then it's going to ask you if you want to save the workspace. I'm not saving it, so no, then no. So going back to our RStudio. So we talked about code completion. So for example, if I want to type, say, I want to load the package, or let's say I want to create a variable called variable 1, 2, 3. Then I tell you 1, 2, 3 is 4 times 5. You can see the way I wrote. This way you assign. You can use equality sign to assign a variable, to assign value to a variable or to an object. or you can use this sign. This one means I'm assigning 4 times 5 to this guy, to variable. You can see the arrow is pointing to the variable. So it means I'm assigning 4 times 5 to that guy. And I can write it another way, this way. I can say 4 times 7 is my variable. I can do it this way too, but this one is more professional this way. So this one is also saying assign 4 times 7 to this guy. So it's still doing the same thing that this guy is doing. So, but we mostly use this first way of writing it. So I don't know. I know this number. So okay, let me go back. So if I should create this variable, say variable 1 to 3, which is 4 times 5, and I run it, it has been this 4 times 5 has been assigned to this variable 1 to 3. So let's say if I want to call this variable 1 to 3, I'll just type var. You can see it's already giving you option var.test, var. So I can just click on this. This is what I want. I'll just click on it. Then it already completed what I wanted to type. Then I'll enter. You can see I have 20 because it's actually 4 times 5, which is the same thing as 20. So that's code completion. Also, we have, let me see if I'm not missing anybody else in this class. Okay. No, okay, it's Farida that is calling me. Okay, he's already here. Okay. Farida, welcome to the class. So also easy access to RF. Easy access to RF. So what do you mean by easy access to RF? So let's say for example, I want to use a function called sum. Now, sum is used. I want to sum 1, 2, 3, 4, 5. If I run this guy, you can see I got 15. So it took 1, it added to the 2, then added to 3 to the last number. That's sum. But suppose I'm just using R for the first time and I don't know how to use the function called sum. How can I go about it? I can type help into bracket sum. This is one way to go about it. If I type help into bracket sum, what happens? Let me run this command. You can see it gave you uh, it pops up the window, the help window at the right bottom here, and gives you a description of how you can use your sum, the arguments, everything that is needed. And also, if you don't want to use this help function, you can say you can type a question mark, and type sum just in front of it. And if I should run this guy, it pops up the same result as you can see in my left. Let me remove it and run it again so that you can see. So let me run this command again. You can see goes to the help window again and give me help on sum. But if I put a double question mark and type sum, what's it going to give me? If I should want this, instead of giving me this, okay, still ready. So instead of giving me that kind of result, it's going to give me a web result, like a web search of how you can use form, gives you documentation and all of that. So it's going to give you a web result compared to the results it gave you at first instance. So depending on which one you want you need to use, I think it is it's still all good. But this first two, it's pretty okay for you compared to this. You can use this when you are maybe searching for help when it comes to packages. You can use this double question mark, basically. why is not part of this program, but make you needed for future information. It's really needed. It's not enough. But I don't think we discuss. So also, I think lastly, what is done with my mouse? I think lastly, easy exploration of variables and values. So how does this where does this come up in our studio? You can see that earlier I created a variable called variable 123 and I assigned 2 4 times 5 to it. If you go to this place, this right top corner, this window in this right top corner, if you go to you can see here, you can see the history of what you have been doing so far here, but that's not what I'm talking about. Now environment, if you go to environment, you're going to see 4.03 4.0.3. I don't
Sorry,
know.
please, can you say again? What version did you say?
Hello?
Hello,
Hello?
you said 4.0.
I mean my R, not my house.
Okay, okay. Really? What
You're
of the
going
R
to be
studio?
house is going to be 1 point something something. Yeah, I don't know what I can get. Let me see what I can get this
Okay.
version. It's going to be 1 point something version. So let me see what I can.
No.
What version is this? I'm trying to see what I can't get the version of my house. But it's going to be, let me check from the web when I got this. So basically, I think what you are going to be getting 1.3 point something. That's, that's going to be the version, house version. Okay, so easy explanation of variables and values. So here you can see under environments, you can see the variable they have created, variable 1 to 2, and it's telling you the value as assigned to is 20. So you can easily explore the variables that you have on your R environment. Let's say I want to even load in a particular data set called iris, which is an inbuilt data set in R. If I say data bucket iris, you can see that an iris data set has been loaded. This is an inbuilt data in R with 150 observations and 5 variables. Everything will be here so that you can easily explore it from here. So moving forward, so RCD is available free of charge for Linux, Windows, and Mac. If you have seen that you read totally free, and RCD can be accessed by clicking the RCD icon in the menu system on the desktop. If you downloaded it, it's going to create a desktop shortcut for you whereby you can click and open. It has the following components: the source, the console, workspace and history, files, plot, package, and help. These are the 4 windows that you have in RStudio. The source is the one at the right, no, at the left top corner, which is this place. This is the source window. Then you have the console. Then third, which is the right top here, is the one we call, sorry, is the one we call workspace and history. That's the one here, workspace and history. Then you have the 5 dot package help and VR window here, which is the fourth window, as you can see here. So those are the 4 important windows we have in RStudio. So here we're talking about doing some simple math in R. We've done some simple arithmetic like addition, multiplication, and all. But here they use the print function to print a particular variable. here we are printing the variable, a string hello world. So I want to use the print function to print that. So print. Now you can see that I'm putting this string in quotes. So if you are writing a string, you have to put it in quotes. It can be either single quote or double quote. Any which way is still okay. So if I should run this, it's going to print hello world to the screen. As you can see here. If I don't want to use print, I can also use a function called paste. Paste is not something as print. You are going to see the difference as you proceed with the next code. I can also use paste hello world. But this you can see, but it's not the same thing. It might work similarly, but it's not. It's more sophisticated than print in some aspects that you want to use. And also, now let me go back. Here you can see that I created a variable called variable123 and I assigned 4 times 5 to it. If I want to see what's inside this variable123, I can either type variable123 explicitly and run it. You see what is inside. Control enter. So if I should run this line, it's going to tell me what is variable123. And also I can use the print function also to print what is inside. I can say print variable123. And see it still gave me the same result. Here it said can also let's create a script that performs mathematical operation in out, create script in out, perform the following step, 3 plus 9 plus 12 minus 7, you perform the operation and you see the result. So you can see this was typed directly into the console, and by the time you click on enter, you get your result immediately in the next line. Now, peradventure you did something like this. I come to the console and I said 3 plus 7 times 3 minus, and I use minus and I press enter. You can see that it didn't bring me anything because I'll assume that you have not completed what you are trying to type. So if you see something like this, means that check the code you are trying to run, check if it is complete and complete it. So maybe I want to put minus 10, I'll just put 10 and enter. Then you complete the program and see the result on that. So when talking about complex mathematical operations now, you can perform the operations as complex as this. It's going to run it for you. Then what are the mathematical operators you are finding now? You have the normal operators like the plus sign, the minus sign, the division sign, the multiplication, then the bracket. And you have a constant called pi, which is 3.142 approximately. Then you have the caret sign used as exponent. If you want to do 2 raised by 3, you use the caret sign, then 2 caret sign, then 3. That's going to do 2 raised by 3 for you. But I think you can use another thing. For example, I want to do 2 raised by 3, I can type 2 caret sign, 2 caret sign 3. That's 8. Then I think I can do this too. Start it. I can use the double star for exponent. 2 star star 3 is still going to give you the same result. Now you have the square root function to take square root, that's sqrt. Then you have trigonometric function like cos, sine, half cos. Then you can use the log function, which takes 2 parameters, the x, the number you're trying to take the log of, and a base parameter. So I want to take a particular number to a particular base, maybe log 5 is 10, log 5 is 4, you can do that. But if you don't provide the second parameter, it's assuming you want to take the natural log of that number. Also, you have modulo sign. The modulo sign is double percentage sign, which is used to find the remainder of a number. So, for instance, if I do 10 modulo 2. So you type 10%, then another percent, then you put 3. Which is going to give you the remainder when you divide 10 by 3. This is 1. Also, you can do integer division. That is, if I do 10 divided by 3, what is the integer number I'm going to get if I do 10 divided by 3? And that's supposed to be 3. The integer I'm going to get without remainder. So if I do 10, so how do you do integer division? You do percentage sign, then this slash, then this followed by this percentage sign again, and you put the next number. So you can see it gave me 3. So that's how you perform integer division in R. So moving forward, now using vectors in R. Vector is the simplest types of data structure in R. Sometimes they say atomic, they use the word atomic vector. If you say atomic vector, you see vector, you're still talking about the same thing. So it's the simplest type of data structure in R. The vector in programming is a one-dimensional array. So it's like it can be, let's say mathematics that talk about the column vector, a line vector. It's just list of maybe numbers or strings in just a single bar, like a list of numbers. So, and how do you create vectors in R? You can use this combine function as small letter C, then a bracket, then put the numbers you need to create or the string you need to create followed by a comma. Or sometimes you want to create a vector of numbers which follows a particular pattern, a sequence. You can use the colon sign. You can see this did 1 colon 5 to create a sequence 1 to 5 in that particular order. Let's run that. So if I want to create a vector of number, I can use C into bracket, small letter C into bracket 2, 4, 1, 4, 5, 2, 3, 1. Then if I run this, you can see it has created that list of numbers for me, as you can see on the screen. Now, another way, I said I can use the colon sign to create a sequence of numbers. So if I want to create a sequence 1, 2, 3 up to 10, I can use 1 colon 10. This is going to create a sequence of numbers. This is a vector, but in a particular order from 1 to 10. Now, it cannot just only take numbers, it can take strings. Now, a vector can only take one data type. It's either it is all numbers or all strings. You can't have a number and a string in a single vector at the same time. It's either it is all of them are all numbers or all of them are all strings. But peradventure, if you put both numbers and strings inside a vector, it's going to convert those other numbers to a string automatically. You should just assume that those numbers are strings. Because it's not supposed to contain both numbers and strings at the same time. Is anybody trying to ask a question? Hello?
It does. It's fun.
It's fun.
I said it's possible to add both number and string to a, like just one variable. From what I used to know, it's possible.
Okay, so let me try it out and you will see. So if I create a vector, C into bracket, and I put 1, 2, 3, 4, 5. I want to put a string inside. This is I have to put in a quote. So let me put hello, and you see the result afterwards. So you can see that all the 1, 2, 3, 4, 5 that I created automatically has been converted to what? To a string, to a character. Right? So it can contain both character and numbers at the same time. So that's all right. So look at this sequence of numbers that I created 1 to 10. I can also use this seq function to create it. It's called the sequence function. So if I say seq, I can say 1, 10. It's going to create a sequence 1 to 10 in that particular order. If I click on enter, you can see I still have the same result. Now, so by virtue, if I want to create a sequence of number whereby I want it to skip maybe the next number, let's say I want to create 1, 3, 5, 7, 9 instead of 1, 2, 3, 4, 5, 7, 9. I want to skip the next number and print the next second and third number, skip the next number and print in that order. I can put write SEQ 1, 10 and I'll put 2 here. So this means print 1, skip the second one, print 3, print the next and skip the next one, print 5, like that, in that order. So if I should run this, you can see I have 1, 3, 5, 7, 9. Now if I should, instead of if I put 3 and I put this one to be 20, it means it's going to skip 2 numbers at the same time. You can see instead of going to have 1, then skip 2, 3, then put 4, then 5, 6 is missing, then 7 in that order. So that's how to use the SCP function. This result is also a vector anyway. So another way you can create a vector is also using a scan command. All of these things we are still going to talk about later, but I just want to just to guess the graph of how you can, in many ways you can create a vector. Let's say if I want to create a vector, I don't want to put the C command and be typing. I just say scan. This scan enables you to just use the flexibility to type the information you need to type in a flexible manner. Now, in this scenario, automatically the way you enter numbers here, if I just put scan, then close, open and close bracket and enter, you can see it gave me a prompt for me to enter my information. Now here, if I want to put 1, 2, 3, 4, 5, 6, I'll put 1 space 2 space 3 space 4 space 5, enter. If I enter, you can see it got 6 here. So it's saying that it's expecting me to enter another element. That's going to be the 6th element anyway. But if I'm saying that if I want to tell the system that I am actually done, then I'm not going to enter anything. Then I'll click on enter again. So it's good to understand that I'm done inputting my values. So if I click on enter, you can see it already read 5 items. 1, 2, 3, 4, 5. Sorry, let me admit someone into the class. Okay, welcome to it. So another way is that you want to use the scan command, and I don't want a space to be what is going to be separating my elements. I can say separator. I can input the separator parameter and put comma in quotes like this. So it means I'm trying to say that the element or the values I want to enter, they are going to be separated by comma. So if I click enter, so if I want to type 1 to 5, yeah, similar. Now if I put 1, so if I want to write 2, I have to type comma to separate it, then comma 3, comma 4, comma 5. Then if I press enter, it's expecting me to enter another value. Maybe I'm not done. Then since I'm actually done, I press enter again. Then it just reads item for me that I've just inserted, which is 1, 2, 3, 4, 5. Okay, you can see that I've been entering numbers. Now, by default, now let me use the scan command again. So scan 1. Now let me now put string hello world, enter again. You can see I have an error. Now, by default, scan is expecting me to put numbers, but I'm typing strings. So how can I override these settings whereby I should be able to put in string when I use the scan command? Then there's a parameter I have to input in this case scenario. So if I put scan, and I'll tell what kind of stuff I want to enter. I'll say what, I'll use the what parameter. I'll say what is equal to what, put in quotes, I'll type character. character. So this is going to make how to understand that what I want to type in are strings, the character values. If I press enter, then I can type hello, then word, then Amy, then let me just put some pattern. Amy, then Henry.
So you don't have to put the quotation mark.
Yes, yes. Since I've told the scan function that what I want to put is character value, whether I put quote, I don't put quotes, it's going to understand that what I'm actually typing is a string already. So just accept it and just do the quoting by itself. So moving forward, please, if you don't get one thing, any what I'm doing at the point, just stop me and ask question. Storing and calculating values. Now we already experiment how to store values into a variable or object. You can see I want to assign the sequence 1 to 5 to x. I'll just put x with less than and the hyphen sign, then put 1 colon 5. I can also use the equality sign to do this, but the I usually use this style, like that's what differentiates them from other programming. So they actually use this style, but you can use the equality sign also. So you can see here they created a variable x at
Sir.
is it? Yeah, I can hear you.
Yes, you said you can use the equality sign, but I think this sign is the one for assignment. Is the equality sign this one going to give us exactly the same thing everywhere?
Yes, it's going to give you the same thing too. So this is it. You can see that I did variable 1 to 3 to be this. I can also say x is equals to, so instead of being used, I would say x is equals to 1 to 5. 1 to 5. Enter. The didn't pop out an error. If I type x and run it, you can see I still have my result. Whether I use less than and hyphen sign, it still works the same way. So, but this is usually used for assignment, but you can also use this too. It still works. Um, so here 1 to 5 was created as x, and here I assigned 10 to y. Then if I do x, so here I'm doing x plus y. Remember, x is 1 to 5, then y is 10. So x plus y is, how is it going to perform the equation? It's going to add 10 to each element in this sequence. So 10 divided to 1, 10 divided to 2, 10 divided to 3, 10 divided to 4, 10 divided to 5, and the result will be printed. You can see 10 plus 1, 11, 10 plus 2 is 12, 10 plus 3, 13.
For assigning values to variables,
Mhm.
the equals also works.
Yes, it works. The equality sign works. That's what I just did here. I assigned x is equal to what, then I printed the x, and this is what I want. So it still works the same.
One thing, what will I put on myself?
It doesn't work that way. But I actually like this style, so it makes you. So if you write this, if you are writing your code and people see this, they will understand that it's how you are using it. Like you are using R, so they will understand your program, that this is output. You know? But then it still works the same. Moving to the next slide. You talk about story and calculating value. Is it not? Sorry, please excuse me. Okay. So, welcome back. Yep. I think we talked about this. I don't know what I say. Let me go to the next slide. Now, it can also talking back to the user. You can also prompt user to enter values. So what do I mean? You can ask the user to enter the value. So like when you go to Facebook and you click on sign up, you just see some text box or some that will ask you to enter some specific information. You can also do that with using the grid line function. So here you can see that here I have age assigned to hello. Then in the next line, you have your name is equals to read line into bracket. What is your name? Question mark. Close it. Now, if I should run this second line here, what you are going to see next is what is your name? So I was going to ask, what is your name? Then you have to type it manually that okay, whatever your name is, type it. Then it's going to accept that information and store it to this variable called your name. So the read line function just prompts gives you a prompt to enter a particular value. That's what it does. So let me come here and tell you what this is. So if I say read line into brackets, they are put in quotes. I can put in quotes. Putting in quotes is just to write a description of what I want it to enter. Say what is your name? Then I can put a colon, then I can put a question mark, then followed by a colon, then put a space so that it will make more sense and readable. So if I click enter, you can see that a prompt followed asking what is your name. So I just have to type, okay, my name is Abiodun Emmanuel. Just type this and edit. Then I click on enter. Then you can see you have the name Abiodun Emmanuel. So that's what readline does for you. But in this case, the information was stored to a variable called your name. So when the user enters the information is going to be stored into this variable. Then afterwards, I can now say in this study, and they said paste h comma your name. Now that's why this is different from print. So paste h comma your name. So this is going to paste hello together with the information that guy entered, which is Andrew. So you can see hello Andrew here. Now automatically, if you put paste h comma your name, whatever the two it's pasting together, it separates it to the space. But you can define your own separator. You can define your own separator. Say you want your separator to be a comma or a space with a comma or a comma with a space, depending. So it can be customized. So for example, let me do the same thing here and say h is equals to hello. Then let me just copy this command. And your name is equals to, let me just copy this. Is equals to, what is it called? Oh, shit. Oh, God. How is this? Why is this thing thinking like this now? Maybe don't understand. Okay, then your name is readline, blah blah blah. Then I let me run this hello. H is equals to hello. So hello has been assigned to H. Then your name. I want this. This is going to, you can see that there is a prompt in the console. Then I'll type my name. Abiodun Emma. Then enter. It has been stored and it's already assigned to what your name. Then the next thing I want to do is paste H comma your name. Automatically by default it separate them with a space, but I want to define my own separator. I will say separator is equals to SEP parameter is called separator parameter. Then I'll put in quotes what I want to separate it with. Then I want to put a comma followed by a space like this. If I should run enter, you can see that my value, you can see that they have hello, then the separator is what, a comma and a space, then followed by your name, which is Abiodun Emmanuel. So it can be customized. Anyway, you can put a semicolon if you like. So So moving forward, now talking about sourcing a script, though I already talked about sourcing a script before, but I'm still going to go by it again. Scripts can be developed in external editors and then imported in R for execution. You can develop your script in Notepad or Word or anything and take it to R and just run it. Doesn't matter. But since you have script editor in your house, this place where you can write your script, but if you feel like it's more security, some other editors can do that. Then sourcing a script. So after you've written, maybe you want to write your script in Notepad, you write your script there, edit your codes there, then save it as a .r extension, then import it to R and run it anywhere you want it. Then script can be sourced in either RGUI or RScript in the following ways. Send an individual line of code from the editor to the console. So I can write my script and just say, let's say this is my script. Say from this print hello world, from this print hello world to this place. So what can I do? I can send the individual line to the console by just saying Ctrl enter, everything will be going to the, or you can say copy, then come to the console and paste it, then run any way you want to do it. Or click the line of code and then press Ctrl R in RGR to execute the instruction. In RStudio, press Ctrl enter or click the run button to execute the instruction. Another way is send a block of highlighted code to the console. So I can highlight the line of code I want to run and run it. It's going to run it top down. So for example, I can come to the house. Let's say I want to run from this place to this place. I'll just highlight everything there, press Ctrl enter, which is going to run it line by line, start from this top to this last line of code. Also, send the entire script to the console. In RGUI, click anywhere in the script window and then choose edit and run all. But in RStudio, click anywhere in the source editor, press Ctrl Shift Enter, or click the source button. What do I mean? If I want to run everything from this 2+3 to this paste line of code, I'll just press Ctrl Shift Enter, then it's going to run everything from top to bottom. Or I click on this source button here, and it's going to run from top to bottom. Okay. So navigating the workspace. So workspace refers to all the variables and functions that are created during any active hour session. The ls function can be used to see the list of variables created in the workspace as follows. So any variable function that I created is going to store in your workspace. So you can see everything here. You can see that I open a particular data set called iris. You can see it here. I created some variables, values, age, which is the value. I created the age which has hello as value. I created a variable 1 to 3 has this corresponding value. I created x which has this value. I created your name which has this value. So everything. So if you want to just list it, you can use the ls command to see everything. Ls command and run. You can see. So you can see these are the variables that have been created for some other sessions too. It's going to bring everything up. But the ones that are created in this my own session is this one, and your name. I created your name and some other ones. But this one has been created long while before this active session. So using the rm function in R, you can use the rm function to remove any variable from the workspace. rm means remove. I can use to remove any variable in the workspace. I can remove it one by one. I can remove it using compiling them as a vector, just remove everything, or following a particular pattern, any which you want to do. So now let's say your name. If I want this, you can see that sorry, I think that is your name. You can see that that's Abiodun Emmanuel. So let's say I'm no longer using this variable again. I can say rm, then I'll put input your name. then it has already removed this variable. Now if I should go on and run this your name, you can see that give me an error, say object your name not found, because that's been removed from the workspace. So I cannot use it again. Now if I want to remove some if I want to remove many variables at the time, I can compile them into a vector. Let me say, for example, I have this particular variable x, and I have this age variable, this x and age variable. So I can say x, let me say x, comma, then put age. Let me run this. You can see that I have a what is it called? I have an error here. It said it must contain names or character string, blah 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 blah. So let me use this. Let me do it this way. So it has been removed. So rm into bracket list is equals to this set of variables. So it has removed these two variables, x and age. So if I call x now, the object not found has been removed. I call age, object not found has been removed. Age, object not found has been. So it has removed these two set of variables. So that's the way you can remove variables from the R environment. Now moving forward also, I say saving your work. You provide following options for saving work. Individual variables can be saved using the save function. You can save it into the out as RDU file. So the entire workspace can be saved using the save.image function. This is actually going to come up automatically when you want to close your R Studio. And the R script file can be saved using the appropriate save menu command in the code editor. Say, for example, I want to save this script. If I want to save this script, I can just say Ctrl S or go to File and click on Save. You can see the shortcut Ctrl plus S. I can do that. If I want to save all, I can use this also. So I can save a particular variable also. Maybe I can even say a list of variables in a particular object. Say, for example, I want to save variables A, B, C. I can just use the save command and put it inside a list and save it as this extension .rtp. That's going to help me save those variables. Then if I want to use it some other time, I'll just load it into the R environment using this command here. Load command. Now that takes us to the end of this session, and this is just a summary of what we have talked about today. I don't think I need to go over the summary again because we have already talked about it from this slide.
So what do we get this now? It's not an area of I'm aware that I'm not supposed to be the past.
Yeah, so Emmanuel, I have a question.
Okay.
So let's say you have your data in a particular database. So how then do you call it out on the R console?
So let me give you an instance. If I'm using Oracle, if I'm using considering an Oracle database, I can just download a driver into my what's it called, Explorer. I save it in a particular location. Then I'm going to, when I open my R Studio, I'm going to connect to that driver, specifying the class path using the RDDBC package. I don't know if I have it here. So using the RDDBC package, let me see. Let me look at the package I have here. So let me see here. Unless if I don't have it here, because I have to install. Okay. So I don't have it here. So I will install the RGDTV package. After I've installed, then I will use the I'll create a connection using the connection string to the database I'm trying to connect to. Use the database name, the password, and I'll provide the two sensitive information and create a connection. So after I've created that connection, then I can now call on the tables I need to work with in that database and work with locally using R. So I can do that. I can do that. I don't have that. I have it in my other PC, but I'm not using that PC at the moment. I would have
Okay, so
I would have shown you how that is actually done.
it's okay. So then the other question is around um, how to combine R and R Studio. Or is it that if you have R Studio, it also contains R as well at the same time?
Yes, yes, exactly. But just download R first from their website, then install download and install R. First of all, first of all, download the R application, then install it, then go and download R Studio, then install.
Okay, thanks.
All right, you're welcome. Bello Faida, how are you doing?
Yes. I'm fine. I'm sorry I came late. I've been trying to log in since saying the meeting has not started.
Oh, wow. That was around what time?
I said 12:20.
Uh, no problem. No problem. Even though the meeting has started. Okay. Um, so let's just quickly go over. I think we still have a lot of time. Let's go to the next session. Where is it? Is it okay. Now here we'll be talking about reading data sets into R, exporting data from R. So let's see the objective we cover here. So here we're talking about import data from external sources into R, export data to external sources from R. Should I? Okay. I don't have that. Okay, I want to show you something, but please give me just 5 minutes. So that I want to show Amos also that stuff I talked about before we proceed on this session. Just 5 minutes. Okay. Welcome back. Let me see the connection. Sorry. So this is scripts. I'll talk into the next one. Okay. So moving forward. So let me show you the stuff I was talking about. So, okay. I'm talking with scripts now. So you have downloaded this the driver as I already said earlier. So, okay, so this so here you started from here, forget about this one. I'm just trying to do something. So you install this package, RJDBC. After this package is installed, you load the library, using the library function. Then this is the link where you download the driver. So I'll try to connect to the Oracle database. So this is the link I'll use to install the driver. So let me copy this link. I'm just going for it. So after copy, then you go to your browser. Then wow. Then so I'll download this Java. Then I will I would store it in a location, and after I've done that, I'll create a connection. So using the JDBC function, and I just call this thing. So I'll create the connection using this JDBC function, and I'll write this. Then I'll specify the class path. That is the location of where the driver is. This is where I stored the driver into location. So after I've created this connection and this object, then I'll use this object I've created to create a connection to the database I'm trying to connect to. So you can see here, and I specify this. Then this is the server I'm trying to connect to. Then this is the username. Then I'll specify the password. Then after I've created that connection, then I can do whatever I want to do with that connection. So that connection name is connection, JDBC connection, and this is another connection I was trying to connect to another server, connection one. Then if I'm trying to connect, so I can now use all this syntax. Yeah, I can now use all the syntax. So look at this one now. I say select if it is just a db get query, and I'll use to get a particular table. So select star from this. So this is going to give me everything in this table and store it to this object. Then I can do whatever thing I want to do with it, depending. Then whether I've probably done a particular I'm done with a particular table, then I want to save it back to the database. I can say right, okay, I don't have the package. I can do write the table and db write table and save it into that database back again. So that's that one, by the way. Okay, moving forward. We've talked about using the combine function to create simple vectors. Uh, Another thing is, I think everything here we talked about it. Okay, we already talked about this. Now, also, here I created data one, which is this number of vectors. Then I want to say, okay, I want to extend this data one. So I want to call data two and say, okay, add these numbers to this data one. So this numbers, these numbers will be added to this data one. So 45734 will be appended to the end of this data, and that will be created as what data 2. You can see after this 9, we have 45734 added to it. So that's our data 2, by the way. So you can use the append function anyways, but in this case, I just use the existing data I've created, then comma, then just get the numbers I need into the C function. Similar thing that they just did here also, but this one is just strings of a vector of strings of characters. Then I've talked about the scan command, how to use the scan command. Okay, that one is inserted also. This is still talking about scan. This one you can, after you run the scan command, you can copy and paste whatever you want. Maybe you have the information in a text file, or so you can copy and just paste on the console and just enter like that. Depending. If it's a CSV file, also comma separated values, you can put inside the scan command that the value is going to be separated by comma, then copy and paste, and that will just be it. Okay. I say use the scan command to create a user string name data3 containing the following values. So we just type scan, then open and close bracket, enter. Then you can type this command, these values separated by space, and that's going to create all these values for us. Then I talk about using separator to put in the values in the scan command. I've also talked about that. Reading a file of data from a disk. Now I can also use scan command to read in a text file. Now you can use scan to read in a text file, but you can't use to read all these standardized file like CSV or Excel. You can use to just transfer like a TXT file that just contain information, but it has to be all character value or all numeric value. It can't be used to read spreadsheet kind of data. You can't use to read spreadsheet kind of data. So you can use this. Say scan file is just the name of the file, the TXT file you want to read. And also you can use file.choose parameter. What do I mean by file.choose? That will enable you to browse through the files you want to select. Now, me running this line of code here means that the particular file I'm trying to call is in my current working directory. That is the location of which the R is using to get documents. So let's say my current working directory is desktop. If I say I want to get a particular file called ab.txt, if ab.txt is not here and I run this kind of command, it's going to tell me that the file does not exist because you cannot find that file in this location. Now, for me to override this kind of issue, then I can use the file.choose command parameter. So let's say scan, I can say scan, then I'll say file.choose. In this manner, sorry, I think that didn't go away. File.choose. Yeah. This is how to choose. File.choose. So it's going to pop up a window now. So you can see the window here. So here, and I can now browse through the location of where my file is. So I can see maybe documents or go to desktop, or if it's under downloads, I can browse through. I can now go to, I don't know whatever. I have a file to open here. It's TXT file person.
You can't specify the path.
And you can also specify the path that you want to use. But I think that one is scarce for me. Let me go to data set. Then I have a TXT file here. So let me do this one. It's going to pop up an error. Anyways, so let me open it. You can see here Is a error blah 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 expecting a number, but what's inside is actually a character. So if I want to provide this error, I have to specify the what parameter and say that what I'm trying to import contains character values. Character. Then I'll run the command again. Then it pops up this, and I go back to where I want to get the file from. Download data sets. I think I got dictionary.txt. Then I'm going to open it. As you can see, it has already loaded this information. It was able to load like 1,000 information, but omitted 51,897 entries. That's which its maximum is still. And if you want to see the rest there, it actually you can actually view it. Anyways. So that is that. Also, you can if you want to see the current working directory you are using, so you can say get wd. You can type get wd and put open close bracket. So this is my working directory. My working directory is document. So it means if I want to call any file from document, I don't need to specify the path. So this is the path. I don't need to specify the path. But if I want to get any file outside document, you can either specify the path or use this particular parameter to browse the file, or you change working directory by using the word set wd. And set wd, you put the path you want to change it to. Maybe so you want to change the path to say I will not come and copy it. So then I say okay, I don't want the document, I want it to download. Then under what data, under download you have data set. Data set. So if I should run this now, my working directory has changed. Then if I type get wd, it's no longer this part. It's not this part now. So any file I want to be working, I want to choose, I can just call it from this location, which is download. Another download I have, what is it again?
Suggested.
He said then another download data sets. Then these are the files that are under data set. Then any file under this place, I can call it directly without specifying the path. If I want to call this guy now, this dictionary.txt, that I wanted to call with the scan command, I can just say file is equals to in quotes dictionary.txt. Then I want it. Then it just ran it for me. It just loaded it for me because I'm in that working directory and the file existed there. Okay, moving forward. All right. Let's go to the next slide. I've talked about using file.choose to browse through the file you want to select. Also, reading bigger data files. I was talking about maybe CSV files, Excel files, table formats, and all. You can use all these functions, read the CSV, read the table, read the delimiter to read tab selected values, kind of files. So all these functions are the ones you can use to read all those kind of spreadsheet data that you work with. So you can use all these ones. So let's say from this location, I want to read this data called employees.csv. Then I can come here and say emp, that's the object I want to put that, is read dot, since it's CSV file, I can say read.csv of employees. I'll put it in quotes. Employees. Remember, I'm writing this explicitly because this employees.csv is my current working directory. Then I'll run it. It has opened since I don't have an error. I'll say add. If I start add emp, it will give me the first 6 records in the employee table. So this is the first 6 records. It's not giving the first 6 because everything inside that file is just 4 records. So that's why it's just giving me 4. So everything is 4 records. So this is what is inside the file. If I type emp, you see now that it's just 4 records that's inside emp. So, you can see that it's just 4 records that is inside. Now also I can use the read.table command to also read this CSV file. I will say read.table, but in this case I will specify the separator value. Since this command separated value is CSV file, I will have to put after this employees.csv, I will have to put the separator parameter, say is equals to what? A comma. And I run. I'm still going to have the same result. Now here you can see that I'm having what? 5 results. 5 results. Now the reason is that if you look at this first guy, it took the first row of my data set to be the header, whereas my data does not have an header in the first place. So it's because it does not have an header, and read.table by default, it assumes that your table does not have an header. But read.csv assumes that your table has an header. So because my table does not have, you can see that it created an header for it by default v1, v2, v3. But read.csv just took the first row and took it as an header. So for me to override this in this first command that I go to read.csv, I have to put a parameter called header is equals to false. So telling that my table does not have, or my data set does not have an header. I can type false by just putting capital F, or false in full like this, the capital letter. I'll just use just capital F like this. And if I should run this command again now, I'll call emp. You can see that it has changed from that part whereby it took the first row as header. Okay, so let's take note of that. And read.delim is used to read tab separated value, and if you're using read.table to read tab separated value, then you have to specify in parameter that you are going to write it this way, a forward slash then t to read a tab separated value in this command, or you just read.delim function directly. So let me see whether I have it. Let me see if I have an example. You can see this one is a TSV file. So body tmp.tsv, body tmp. So let me read this file. So body tmp. So let me say body temp. Body temp is equals to read.delim of body tmp.tsv. So let me run it.
Yeah.
The TSV file. Yeah.
Yes.
So head of body temp. So this is what is inside the file. I think it does not have an header too. You can see that the way the guy was read is not okay. So I have to put header is equals to false. Header is equals to false. Then run it again. So this is where it's supposed to be.
Can we show the CSV file?
A tab separated value file.
That's separated value. Okay.
So if I want to read it using read.table, and I'll put this separator parameter as /t, then I'll run it. I have, oh sorry, sorry, this is not. I'll put body.tmp, body temp.tsv, and I run it. Uh, so this is my result, which is similar to what this my command gave me. So that's it. By the way, this is the separator for CSV file. Then for comma separator value, we put comma as the separator. Okay, moving forward. Let me close this window. Missing values in data files. So in real world, samples are often of unequal size. So let's consider two samples, more and unmoved. The more samples contain like 5 values, whereas the unmoved samples contains 4 values. When the data is read into R from a spreadsheet or text file, the program will recognize multiple columns of data and set them accordingly. Blah 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 blah. And just this stories. So we're just talking about missing value. Now, so what we try to say in essence is that, oh, sorry, they didn't give us an illustration of what they were talking about here. So let's say I have two sets of values. So let's say before I go to this place, I have value 1, 1 to 8, 1 to 8. And I have, no, sorry, I have value 2. Let me run this guy. And I have value 2 to be 11 to 20. Now, we know that this value 1 is of length 8 and this value 2 is of length 10. They don't have the same length. Now, if I do something like this, if I should bind both of them, bind means combine, only 1 value 2. So you can see this error, and this one, it didn't pop up with an error, but gave a warning that number of rows of results is not multiple of vector length. Because if you see that value 1 is what 1 to 8. Now this is value 2, which is length was 20, but when 1 to 8 was exceeded to this point, what happened? It now started filling for the remaining length that does not match with that value 2, starting from the beginning. The cells, when it stopped at 8, they start from 1 to 2 to fill in the gap. But this is not, if I want to create this as a data frame, it's not going to even come up at all. It's going to throw up an error. If I want to create as a data frame, I'll say data.frame of v1, v2. If I do this, it didn't even come up. It didn't come up because it said arguments implied differing number of rows, 8, 10. V1 is 8 and V2 is 10, so you cannot even create it in the first place. Now, for me to be able to create this 2 as a data frame, it means that I have to complete maybe this V1 to be of size 10. So the remaining part that is not complete, I can just fill in with the missing value, say combine V1 with, I want to repeat n 80 times. Don't mind where I'm writing this thing. It's not something new. I just don't want to write NA, NA. Doesn't matter. So this REP means repeat NA 80 times. So if I should run this now, let me print what V1 is. You can see that you have 1 to 8, then you have NA, NA. Then if I should create data frame V1, V2 now, it's going to create now. Then you can see that the next two values is just NA, NA. Then it's already sorted. So that's how to do missing values. Missing values are defined with NA. Now, how do I know whether there is a missing value in the data set? I can say is .NA of V1. If I say is .NA of V1, it's going to give me true wherever there is missing value. You can see that the last two gave me true because the last two values in B1 is a missing value. But what if I want to see those missing values exactly? I can just say B1. Let me go too far. I'm going to get difficulty. So moving forward. Now exporting data from R. That is okay. I've worked with the file. I've cleaned it. I've done a lot of things with it. I've allocated it. Then I want to save it as maybe a CSV file or anything like that. Then I can use this, write the table, write the CSV, whatever I need it. So here I rewrite the table. I can use write the CSV. You save it automatically as a CSV file. Then I can use write the table depending on if you want to save it as a tab separated value. I can use that. So write the table. I'll specify the file I'm trying to save. Let's say I'm trying to save. For example, I've worked with this file called EMP, and I want to save it as say a CSV file. I can say write.csv of first of all, I want to add some information to it. So EMP, this is EMP. Shania, NA, blah blah blah. So I want to add some value to it. Let me say something first. I can't use this yet. Sorry. Head summary of class. Yeah. I don't mind the character, logical, blah blah blah. So I want to add values to this EMP table. Then I can say EMP 05 sorry. This is my fifth row, right? Then I want to add a sixth row to it. And the sixth row is going to be, let's say, Abiodun, then I have to put this in quotes. Abiodun, NA, which is second, then Emmanuel, Emmanuel, then Emmanuel is maybe a programmer, then Emmanuel is a male, maybe Emmanuel was given that in the let's say 24th of November 1990, and maybe Emmanuel now died in the year 13th of August 2079. Okay, anyone this. Okay, so and I want to see the update I've just made in EMP. I can see the information here at this bottom here that they added to it. So now I've finished working with this file and I want to export it to locally on my PC. I can say as a CSV file, for example, write.csv. Then what's the name of the file I'm trying to save? EMP. That's the name of the data I'm trying to save. So what do I want to save it as? File is equals to, I'll put in quote, my emp.csv. That's what I want to save it as. Now, if it's okay like this, but if I should save it like this, it's going to save this 1, 2, 3, this row index is going to be saved along with it. I don't want this row index to be saved along with it. Then I'll put a parameter called row.names row.names is equal to false. I don't want this 1, 2, 3 this index to come with this. I'll put this. Then I'll run it. So it's already saved, but it's going to be saved in your working directory. And where's my working directory? It was I changed to download data set under download. So if I go to data set under download, I think this is it. Then I can see it here. My EMP.
Last one.
Okay,
The last one.
okay. So yes. Now if I should open it now, you will see what I have inside. So all this information I've written is going to be in that file. Now I can use like the table, put the what's the file I want to save, what do I want to save it as, uh, what is the separator, and do I want to include the row names or not, then I specify also. Okay, next, saving your work in how I can save my work using the save command, then give it a name. This is the work. Abiodun, this is the latest information I updated to it and all of that. So that's it. So what else again? So here you can see they just gave us an instance. So I want to save this object bf.lm, bf.beta, these three objects. I want to save it into this file called file name here .out data. That's the extension to save objects. So save as .out data. Another way I can save a particular file that follows a particular pattern using this. This one is saying save the file that starts with bf. All the objects that start with bf that are created, save into this file. This one is saying that save everything in my workspace that I've saved, all.true, yes, this is all.true, saved into this file name. Then if I want to save the whole entire session, I can say save.image into this file name. That's how you can go about that. Now for saving data to this surface file, data can be transferred out of R by using the i.table we talked about. So I think those are the important ones, and that will be it for this session. I think it was time. It's already 2 o'clock. It's already 2 o'clock. So that is that for this session. Do you have any question before we call it a day for today?
Yes, my own question is this. The last save method that you showed, that means everything that happened on the console, that's what's going to be saved there by.
Yes, exactly.
Okay. So if you want to say push your work to say GitHub, can I use that file, like that file that's going to be saved using that method and push that one to GitHub? Is that going to be okay?
If you want to do that, you can just save everything that is on this with this windows, this editor window. You can just write your commands, your codes, in this as a script. It's better than you understand.
What is it?
You can save your, is it like the codes or the art or
Like
the code or
the out.
the code and the output all together?
Yes.
That one is going to be saved as an image, like a kind of,
Using the last number.
yes,
Okay.
yes, exactly. So, all right. So that's good. Any other question?
Yes, what I said, the thing you asked us to download yesterday, I wasn't able to do so.
Yes, yes. So let me see. if you log in using my access, it means you come to this place, you will be here, you'll be able to see. Do you see this? Do you see this?
Yes, yes, I see that.
So if I go to page 2 now, I'll be able to see this lab manual or what. Then if I click on resume course, sorry, if I click on resume course,
For the
yes. So if I click on that, I will see this particular thing, download analyst data for lab. Let me click on it. Let's see. I did for yesterday. So if I click on it, you can see that it has started download. Can you see it here? Exactly. That's what I just want to see. You can see it's of 8.3 gigabytes. So I have this already, so I don't need to download it. So I'll just go and stop it.
8.3 gig. Wow.
Yes.
Nice
So
one.
I told you yes, I'll just pause it because I don't need it. I downloaded it.
Hi,
So they want
Emmanuel.
to use
Hello, yes?
Well, we're gonna keep something like that.
It's just a small so we have people that keep movies on their PC that okay, well it's going to take a lot because it's zip file, so it's compressed. Hello, I can hear you. Are you trying to say something?